All right, so continuing with the practice test, this is section 3.2, and this is on solutions to systems of inequalities. So what we should do here is change these into slope-intercept form, because it's usually easier to graph like that. Negative 3y greater than or equal to, if I subtract x from both sides, I would get this. And then I'll divide everything by negative 3, so it's y rather than negative 3y. So remember, when you divide by a negative number, this sign right here has to change direction. So I just made it change direction. And that's like a negative 1 over negative 3, which is a positive 1/3. And then 9 over negative 3 is minus 3. So let's graph that. So 1/3 x minus 3, that's a y-intercept of negative 3. And the slope means go up 1 over 3. So we'll do that. We'll go down 1 to the left 3 also. Okay, this should be a solid line because y is less than or equal to, so it's a solid line, which looks like this. And then I'm going to hold off for a second on the greater than and less than part. We'll wait until we have the other one so we can see where to shade. Okay, this one, if we change it to slope-intercept form, we would subtract 4x, so we're going to get this over here. We'll get 3y greater than negative 4x plus 6. I don't have to switch the sign because I'm dividing by a positive 3 this time. So y is greater than negative 4 over 3x plus 6 over 3 is plus 2. So there's our second equation. It has a y-intercept of 2, and the slope is negative 4 over 3. So we go down 4 over 3. And this should be a dotted line, not a solid line, because that's y is greater than, not greater than, equal to. So there's our dotted line. Okay, and you may notice this kind of forms what you could say are 4 regions, and we'll call this region A, B, C, and D. So let's figure out where to shade first based on this one. So this says y is greater than the red line. If you look at that red line, A and B are above it. A and B are greater than it. So we're going to be shading somewhere in A and B, although we don't know where yet. How do we decide? We look at this one now, and it says y is less than the green line. So if you look at regions A and B, A is not less than the green line. A is, here's the green line right here. A is above it, B is less than it, so we have to shade in this zone right here for our inequality. Okay, 10 is done the same way. We will put each of these in slope-intercept form, so let's subtract x from both sides. We'll get 3y greater than negative x minus 6, and then we'll solve for y by dividing by 3. So we're going to get y is greater than, this is negative 1 over 3, so negative 1/3 x. And then negative 6 over 3 is minus 2. So there's our first equation. Should be a dotted line because y is greater than. So the y-intercept is negative 2. The slope is negative 1 and then over 3. Okay, or you can go up 1 to the left 3. And this should, like I said, be a dotted line because it's y is greater than. Okay, just to save some time, when you change this to slope-intercept, you would subtract the 4x and then divide by 3, and that turns out to be negative 4/3 x plus 1. This should also be a dotted line that has a y-intercept at 1 and a slope of down 4 over 3. So I'm just going to make a dotted line right there. And you can see again we get 4 regions, which I'll label here. Region A, doesn't matter which one you call them, just using letters A, B, C, and D. Okay, it says y is greater than the red line. So if you look at greater than the red line, that's regions B and C, which are above. A and D are below the red line, so we couldn't be shading there. And then how do we decide which one of B and C? Well, this one, the purple line, y is greater than the purple line. Out of B and C, only B is in a zone that is greater than the purple line. It's above the purple line, so that's where we would shade. All right, number 11 is on something called linear programming. Okay, and what it means is we have to graph these top 3 things, and then finally at the end we'll plug in our value. So they kind of tell you here, it says graph the system first. That's his first step, so let's graph this. So we'll graph negative 8. Y is between negative 8 and negative 2. So y is equal to negative 8 right here at this horizontal line. Okay, y is equal to negative 2 right here at this horizontal line. And then we're between that because y, it says y is in the middle of those. Y is greater than negative 8 but less than negative 2. So we're going to be somewhere in that between those green lines. Okay, this one, y is less than or equal to x. Well, that's the same as 1x plus 0 in slope-intercept form. It has a y-intercept of 0, and the slope means go up 1 over 1, or let's go down 1 to the left 1 because we're supposed to be down in this zone right here. So I'm going down 1, left 1, and that you can see that has a positive slope. This should be a solid line, by the way, too, because it's less than or equal to. So let's just connect the dots right there. And what's going to happen is we're going to end up forming some kind of region here that we can work with. This last one says the slope-intercept form. The intercept is 10, and the slope is that's negative 3 over 1. So go down 3, right 1. Okay, so we'll do that a couple more times. Just gotta be careful that I count this correctly. So down 3 over 1. Now we're in the region that we want. So down 3 over 1. That will be negative 8. Okay, so there's our other region right there. Just make a reasonably straight line. Okay, and then we said before that we're between those green lines, and I'm going to shade where we are. So if you look at, it says y is less than that purple line, so less than means over here, but we don't want to shade up here because we have to be between the two lines. So less than the purple line is here, and this says less than the red line, which is over here. Okay, so how did I know to shade that area? Because we said at the very beginning y is between the green lines. So we have this region, it looks like kind of a trapezoid. And it says find the coordinates of the vertices. The vertices means the coordinates of that trapezoid. Okay, so this line right here, this orange line is y equals negative 2. So I know that the y coordinates for these vertices are going to be negative 2. And similarly down here, I know that that line is negative 8. The vertices for that one are going to be negative 8. Okay, so how do I find the x's? Well, all I need to do is basically I can either plug it into these purple lines or I can just eye it. So the purple line is negative 3x plus 10 equals y. And I know that y is negative 2. So let me just solve that for x. So I'll subtract 10 from both sides. I get negative 3x equals negative 12. Divide by negative 3. X equals 4. So that's right here. And I got that by using this purple line here, the equation for it, and plugging in the y that I knew. Okay, same thing over here. If you plug negative 2, this is now on the red line. So if you remember the red line, the equation for it, I should move it down just a little so you can see it. Here's the equation for the red line. If you plug in negative 2 for y, we're setting it equal because it's right on the line. It's not greater than or less 2 at that vertex. Actually, we didn't have to solve anything. X equals negative 2, which is kind of given to us. So there's our next coordinate. Down here, the purple line, same reasoning. Now I would plug in negative 8 to this equation. And when you do that, you end up with x equaling 6. And you can kind of see, well, you can't really see because it's a mess, but x is 6 right there. And then same thing, if you plug in negative 8 to this equation right here, that means x is negative 8 too. So let's read what they're asking us. Graph it. Well, we did graph it. Find the coordinates. We found the coordinates. Then find the maximum and minimum values of the function. What's the function? Okay, the function is this thing right here that we haven't touched yet. So the way that we do this is we take those coordinates that we have and we're just going to plug them in to this function, 5x plus 14y, and they want us to find the maximum and minimum values. So our 4 coordinates are these ones right here. So I'm just going to write those in the table. So negative 2, 4, negative 2. We have negative 8, and we have 6, negative 8. So let's just plug those in, and we should be able to come up with a maximum and minimum. So 5x plus 4y would be 5 times negative 2 plus, that's 14 times negative 2. Okay, the next one should be 5x, so 5 times 4 this time. And I'm getting these numbers from this coordinate right here, plus 14 times y, 14 times negative 2. This one is 5 times x, 5 times negative 8, plus 14 times y, 14 times negative 8. And this last one is 5x, 5 times 6, plus 14 times y, 14 times negative 8. So now we just need to calculate these. So this top one is negative 10 plus negative 28, that's negative 38. This one is 20 plus negative 28 is negative 8. This one is negative 40 plus negative 112, negative 152. This last one, 30 plus negative 112, negative 82. The minimum value up here, actually that's the maximum value right there. The minimum value is negative 152. That's the smallest number. So that's how we would set that up. Okay, this system of equations has 3 variables. So what you have to do here is pick a variable to eliminate. It doesn't matter which one, but then you need to consistently stay with that. So what, just looking, I'm going to pick y because this is a 1y, so that's probably the easiest one to do. So I'm going to reuse this second equation exactly as is. I'm not going to touch that. And then I want to eliminate the y, which means I have to multiply this top one. This is a negative 2y right here. So I need the top one to be a 2y. So I'm going to distribute the 2 to everything. If you distribute this 2 to the top, you would get 6x plus 2 times y is 2y, 2 times z is 2z, and 2 times 3 is 6. Now I can eliminate the y's by adding them together, because that's a positive 2y, that's a negative 2y. 6x plus negative x is 5x. Okay, those go away. 2z plus 2z is 4z. And 6 plus negative 4 is 2. So when I have it down to 2 variables, I'm going to box it off. And the reason I do that is because we know how to solve equations with 2 variables. We did that before. What we don't know how to do is solve with 3. So when I get something down to 2, I want to save that so I can use it later. Okay, here's the key thing. We've used the top 2. We used this one and we used this one. Our next elimination has to use this third one. It's the only one we haven't used yet. And we need to use it, because otherwise, in fact, that's the only option. We can't use the first 2. We've already used those. Doesn't matter which of the first 2 you use, but I'm going to choose to use the first one. And that's because I'm trying to, the other thing I forgot to mention, you have to eliminate, we eliminated y. So we need to stay with that. We need to eliminate y during the second one. So the way that I would do that is I have a 3y right here. That means I need this top one to be 3y. So that's why I'm choosing to distribute 3 to everything. 3 times 3x is 9x, and 3 times the y is 3y, 3 times the z is 3z, 3 times 3 is 9. Okay, how would I eliminate the y? This time I have to do it by subtracting. I'm going to subtract all these right here. And actually, I'm going to write the answer over here next to my other equation, because I'm going to end up eliminating those together. Okay, so 9x minus negative 2 is like plus 2. That's 11x. I'm just going to write this over here. Okay, 3y minus 3, that's eliminated. 3z minus 3z, that's eliminated too. 9 minus negative 13, that's like 9 plus 13, which is equal to 22. So this is actually easier than we thought. We would have to normally do another elimination. There would be a z there, and we'd do another one. We don't this time. We can just solve directly for x and get x equals 2. Where do I plug in x equals 2? I plug it in right here, because that only has 2 variables. If you plug it into the original, it's not going to work. So let's just double check that we have this. X equals 2, that's the first answer. Let's plug in 2 right here. So 5 times 2 plus 4z equals 2. 5 times 2 is 10 plus 4z equals 2. Let's subtract the 10 from both sides. We get 4z equals negative 8 divided by 4, and z is equal to negative 2. So now we have x and we have z. Let's solve for y right now. Let's just pick any one of these equations. I'll pick the last one, and we'll plug in the values that we just found. So we found that x equals 2. We found that z equals negative 2. Negative 2 times 2 is negative 4. I'm going to put this next to it. 3 plus negative 2 is negative 6, and we still have this 3y right here. Just kind of rearranging things. Negative 6 plus negative 4 is negative 10. And then let's solve for y by adding 10 to both sides. Negative 13 plus 10 is negative 3, and that's equal to 3y. You divide by 3, you would get y is equal to negative 1. So the way they usually write this is in order x, comma y, comma z in alphabetical order. So x equals 2, y equals negative 1, z equals negative 2. Okay, these are matrices, and we'll finish this video with these problems. Matrices, to add them, you just add the corresponding elements. So negative 3 plus negative 1 is negative 4. Negative 3 plus 2 is negative 1. 2 plus negative 3 is negative 1. You can only add matrices when they have the same dimensions with those do. Okay, same thing over here. Let's just add them. So the top one is going to be 5 plus 0, and that's 5. Negative 6 plus 4 is negative 2. Okay, then the next row we have 2 plus negative 1 is 1. Negative 5 plus negative 1 is negative 6. That checks out. 6 plus negative 3 is 3. 1 plus 4 is 5. So that's that answer right there. This one is called, on the right, on the left, is called scalar multiplication, and that just means you distribute the negative 4. So negative 4 times 6 is negative 24. Negative 4 times 3 is negative 12. And negative 4 times 0 equals 0. Okay, and then the last one is done the same way. It's still scalar multiplication. So 5 times 1 is 5. 5 times negative 6 is negative 30. 5 times 3 is 15. 5 times 1 is 5. 5 times 2 is 10. 5 times 6 is 30. And so there's our bottom matrix. So that's called scalar multiplication. In the next video, what we'll do is we'll talk about how to do a little bit more complicated types of multiplication, like number 19.